Hello and welcome to the second installment in the Open Crowbar video sequence. Today we are going to be showing the booting the admin server process. So we have a previous video where we've set up the environment. We focused on Windows. I'm using an Ubuntu 12.04 system this time. Keep things up, show you a little bit about how the different environments go. The basics that we're showing in this video are independent of that. But we'll walk through the actual bootstrapping process and what's going on with this. So fundamentally, we've already shown the screen. I'll walk you through the UI in a moment as we boot things. But this is a Crowbar infrastructure that has the admin node provisioned. So the systems overview breaks down all the roles into functional divisions. The Open Crowbar one mostly brings up core and networking infrastructure. We'll see how that changes as we bring up some other nodes. So let me do that without any further ado. This is my Crowbar admin system right here. I have a session into it. I'm actually running this one in a Docker container, which is very fast and convenient if you're going to be cycling through this several times. I highly recommend trying the Docker version because it's faster to repeat and recycle. If you want to play with it, VMs are a perfectly good way to do it. From there, we have a small script that makes things pretty easy that sets up a KVM slave. So I checked out the code and I'm using one of our KVM slave tools. You can also set up your own virtual machines using VirtualBox, VMware. It really doesn't matter as long as you set up the appropriate network connections. In this case, these slaves are going to be connected into the system. I'm going to go ahead and start 3 of them, all running in background windows here. And in this case, they're starting with an empty disk. So we just basically build a VM shell, we boot the machines, they PXE boot. Crowbar downloads a discovery image. This is part of the normal provisioning process for us. There's a lot of different ways for Crowbar to learn about nodes. The default one here is to use DHCP and PXE, go and load a discovery image, which it's doing right now based on CentOS. We call that image Sledgehammer, and we use that as our pre-execution environment. Sometimes I'll call that sideband control. The OS hasn't been provisioned yet, and so we have an environment where we can access all the hardware infrastructure, do some inventory and discovery, do management and controls. This system will persist in this state until we decide it's time to move on to the next step. So you can actually take advantage of Sledgehammer as an operating environment. We put the keys in, we attach it to the correct networks, and use that as a burn-in environment. One of the things Racken has done in extending Open Crowbar is added burn-in steps into the sequence so you can run custom burn-in tests to make sure your gear is up to date. So it's going to go through and boot. I launched 3 of these, so we'll actually have 3 different systems going up and booting. It's minimizing them so they're very tiny little KVM instances. Oops. Let me expand one out. There you go. It's nice to keep these around. They'll disappear as soon as I go through a reboot. But once they've been discovered, you'll see them get added into this screen. You also see we track number of node roles in process in the top right corner of the screen, so we can watch in the background as things progress. Just bring this over here so I can watch it out of the corner of our respective eyes. So this is the key screen for Crowbar. This is our system deployment screen. You can create sub-deployments. We'll show you how to do that as we go into the next steps in our progression. That's about building ready state in the next video. And each one of these what we call node roles, these green checks, represents a concrete service within the infrastructure. Some of them are what we would call milestone roles. So they don't represent an actual install, they represent a chain of things leading up to it. And so there's a dependency graph that's being built to make this work. And in doing that, we know how things are related and how they have to be installed and brought together. This will be more interesting when the other machines come in. But to bring up a Crowbar environment, we actually have to bring up or attach to a full operating infrastructure. So we need to bring in Chef, DNS servers, console service for service discovery and registration, a DNS server, NTP, logging, DHCP. All of these components are necessary to run a data center. Crowbar has to install them in order to get running. We're actually making some changes in this coming release to turn these into services and leverage existing provisioning tools, DHCP, DNS, in addition to or instead of the ones that we've built inherently into Crowbar. So a lot of new flexibility coming in this next release today. Our expectation is that you can run a DHCP server. If you contact Racken, we can help you use existing DHCP infrastructure or existing cobbler infrastructure. Those are definitely possible. And in this case, you can see the servers have come up. They're being discovered. The first thing that Crowbar is doing is it's making DNS entries. So we're aware of these servers. We have to create DNS records for them. Then we have to create DHCP boot records for them. So we have provisioning control. That'll tell us what we're going to boot the next time it boots. So all those changes come through, and you'll notice that Crowbar is literally going through and making operational changes to get these systems ready to work. And then it'll go in and it'll start doing the provisioning against it. So it's installed the Chef client, it's going to build the admin network, and literally attach these newly discovered nodes into the operations fabric of the system. What's going on behind the scenes is we've built up a list of work, and we're very excited about how we do this. We call it annealing. It's part of having a very flexible graph system that is able to accommodate changes and interconnections within a physical environment. It's really a graph system designed for physical infrastructure. So what's happening is we have a couple of things that are operating. These can operate in parallel. And then each one, you can see there's additional actions that are blocked. If I go to the specific node, you can see a similar view. These are all the activities that need to happen on this node. As we go further down the provisioning chain, we'll add additional steps and components and pieces. And this is a very extensible part of Crowbar. It's designed with our principle of late binding, where each one of these steps can be added into the environment, and nodes can be very dynamic and shifting as you add things to them. You don't have to decide up front how to resolve this graph. It's literally resolved dynamically. It's part of our operational philosophy for how this operates. We've built some networks, and then we've identified a whole bunch of attributes. So we track a huge amount of data, part of the functional operations paradigm that we follow, where we separate each node role into a very defined unit of work. That means we have to pass information in and out. That's what attributes do for this. And so you can expose attributes both for needing them and for taking them. And then we have some where you can expose them in the APIs so that you have additional capabilities. And along those lines, let me show you the API or the CLI. So in the Crowbar CLI, I can type in a command like Crowbar nodes list, and it'll show me all the nodes. I could say Crowbar nodes. I could use the names or the database index, and it's going to give me all the JSON that's available for that node. That's quite a number, quite a bit of data here. And then I can also make changes and put and take. I don't have to inject the whole JSON. I can just overwrite the values that I want to overwrite. And so if you go through the system, we have a nodes view where we show the nodes. They've all completed. One of the things that's really interesting for Crowbar is that we don't consider nodes having a discrete state. The state is actually a sum of all of the actions that are pending and completed. So when nodes are in transition, then they'll be shown as being in this intermediate state. In the interest of time, what I want to do is I want to point out a couple of things and then kick us into the next phase of the deployment. So you'll see these nodes don't need all the roles, and they actually have their own roles. So they have a logging client that attaches to the logging server. So these things are all pre-baked into each other. You'll see the clients are coming in as we get the new pieces and parts in here. And then node discovered is its own distinct milestone. And so that becomes the part here, and they're not admins. So there's a fair bit of granularity in how the graph is resolved, but you wouldn't deploy an application in the system graph where we're dealing with operations tools. What you would want to do is use the Ready State Wizard. And the Ready State Wizard isn't anything fancy. It just pulls together discrete provisioning steps into a single unit. In this case, what it will do is it'll build us a deployment that we'll call pilot. In this case, it'll say that for that pilot deployment, we want to use the second NIC, second 1 gig NIC. So 1G, 1 gig, 1 is the second interface. And it'll find that in an abstract way. There's a lot of things that we can do with this nomenclature. It's beyond the scope of the video, but it allows you to abstract out networking so that you can have the same networking applied no matter if you're using VMs or hardware or even Docker containers to an extent. So abstracting the network has been very important from a functional operations perspective so that your scripts will run in every environment. We give it a range for that network. Crowbar automatically adds IPv6. I'll show you some of how that works. Our core default is IPv6, and we use IPv4 as an overlay. And then we have the option to bring up nodes. So these are the discovered nodes. They've been inventoried, so you can see some information about them. And then I can pick operating systems. And to make things more colorful, I'm going to pick different operating systems for each one. I'll run the wizard. The wizard is just building the network, the deployment, putting the nodes in the deployment. I could go in, I'm in the proposed state right now, so we haven't taken any action, and I could change the operating system if I wanted. And then OS installed is a milestone, so it's not actually, it doesn't do anything, it just rolls up other things. If I wanted, we've added a pilot network. If I was going to install PackStack, I could do that here and add that into the infrastructure. I'll go ahead and do that for illustration. Please consult the PackStack video where we go into a lot more detail on how this works, but I can pick one of my nodes to be my PackStack node. And what you'll see is this is a milestone, and then that first node requires me to have the PackStack base and the PackStack node. Additional ones don't require that, so the system's smart enough to figure out the dependency graph and put things in the appropriate places. And then just like choosing an OS, I could switch to different releases of OpenStack for installation. In this case, that one I won't install PackStack on this third node because I didn't select it. Committing at this point will then tell the system, hey, it's time to make all these changes. We don't see these as provisioning operations so much as a sort of upgrade or continuous stabilization. So we've told the system you have to make some changes. You'll see it's really interesting. It goes in and adds the pilot network. Pilot network's part of these nodes now. It actually added it to Sledgehammer even though it was just about to tear Sledgehammer down. And you can use effects like this to be able to do work in Sledgehammer. It's part of our graph resolution so that you can do burn-in or testing or some network discovery configuration. If I'd added the RAID and BIOS configuration, those could take action inside Sledgehammer and do certain types of activities. System just went down, that means it's rebooting. We're back in the system deployment where we're going to show how changes are coming in. And here's one of the nodes being rebooted. Here's another node being rebooted, and here is the third node being rebooted. And what's happened is for each one of these nodes, we have set the next OS to boot. We've told it what pilot it's in, and it's going through the process. And you'll see here I have reboot since they're virtual machines, and I know that the only action I have is reboot. If I had physical hardware, like I'll show in another video, I would expose additional operations based on what the hardware was capable of. So reboot, power lights, identifications, things like that. The other things to show in here, there's a bulk edit where you can set a whole bunch of things at a time, change the aliases and names and deployments. Networks show the networks that we've created. So in this case, we have the administrative network is the one that's built by default. We have a special BMC network that is for the out-of-band management. You can see all of my different OSs are installing. So I have my CentOS network, I have Ubuntu, and I have Cent 7, so 6.5, Ubuntu and Cent 7. And then I have my pilot network. This is the one we just built. I could add others and make them part of the dependency. So when you have a deployment, you can inject a network. That network becomes part of your install dependencies, and you could set it as a prereq so an install would fail if it didn't have the right network set up. And one of the things that we've done that's really important is if any one action has a problem, let me show you this. So for example, my admin network here, this is the admin network. I can see all the allocations and the data. And then we have very concrete logging. So as these actions happen, we track the logging so you can see exactly what was done in each step. One of the benefits of keeping the steps very small is that you have very concrete troubleshootable items. That nice back formation to troubleshoot. And then if something fails, you can literally fix it and retry. Sometimes there'll be a network timeout that's very common in some of these deployments, and you can just retry, and a lot of times that will resolve if there was a network failure. And then so we can come in here, look at the pilot network. We can see the added description, the conduit it attaches to its IPv6, and then ranges that have been set up for that system. So we've built a host network and an IPv6 range that will get allocated as that network is built up. We also have additional views that help you resolve which IP addresses have been assigned to which networks and which networks are on which nodes. None of these are physical, so there's no BMC. And then this allows you to deal with the fact that different systems enumerate NICs in different ways. So it's very important that if you have a system, you want to be able to identify NIC enumeration and normalize that. And this is a process by which we normalize NIC enumeration so that you can consistently have your environment specific to you have the 10 gig NICs enumerated in the correct sequence, even if they come up as ETH0. We've had this for a long time. It's an essential. When you need it, you absolutely need it. So after we've looked at the networks and bus interfaces on the deployments, we've shown you the deployment side. This is a new install, by the way. I slipped one in between while I paused after networking. You can take a look at all the roles. It's important when you look at roles to understand that each role is implemented by a different jig. Jig is our abstraction interface. So when each role is executed, it can be done by a different implementation mechanism. In some cases, that's a script, so that's actually a bash shell action. No-op does nothing. We use that for checkpoints and milestones. Ends up being a very important part of the orchestration system, so that you can have other roles that depend on a milestone, and then basically create a series of gates for your deployment, and then extend the orchestration around those gate points. Ends up being a critical architectural design component. We didn't realize how important it would be until after we'd put it in. Test jigs are used for our offline tests, so we can test without having to deploy physical infrastructure. Chef Solo is an older jig. We used to use it before we switched to using Chef Server, so it's basically runs without the Chef Server being required. It is functionally equivalent to the Chef jig, except that you can't use encrypted data bags with it. Puppet standalone, very similar concept. If you had Puppet modules that you wanted to execute. Role provided jig is a new concept that we're using for some of the burn-in and system validation. And then a lot of the core work we have is Chef, because that's historically what we've used for Crowbar. So we were able to reuse significant amounts of code from Crowbar 1 by reusing the Chef jig. And it's important to note that the Chef client is installed by the script jig, just like Salt Stack or Puppet. That's how you bootstrap through the system. System overview, the annealer. When the system's operating, it's going to show you what work is in different states. It's a convenient way to track what's happening with the system. The system overview here is designed to help sort of see the system at the high level. It's really useful when there are a lot of nodes and what it does is it'll show you what type of work is going on within the system in a functional sort of way. So you can see operating systems being deployed, nodes being brought up. I call this the CIO view. It's useful to sort of see how busy your infrastructure is. And then under utilities, we have a series of things. Bootstrapping is used if you don't provide the defaults. You can use the bootstrapping screen to populate all the critical data if you weren't using our production.sh script. Exported items is used to retrieve log files. Installed jigs will show you all the different jigs that are in operation. See, there's quite a number of them for roles. The test one's not activated. If you ran in development mode, a lot of these jigs wouldn't be installed. Bar clamps are a legacy concept from Crowbar 1. Really, they're groupings of roles. Then those are then bundled into workloads. It used to be that you had to have a GitHub repo for every bar clamp. We did away with that, and so something like OpenStack, which in Crowbar 1 would have 10 or 15 different bar clamp and GitHub repos. Those would still be bar clamps, but they would be managed as a single workload. And then we have some user management. So there is password and user identities with admin and non-admin credentials. And if you're going to do API work, these have to be set as API enabled. So that's what Machine Install and Crowbar both operate as API enabled users. And there's also a user setting, so your user can actually decide if it wants to show additional information or hide additional information and change refresh rates. Sort of primitive. And then the help is just a rendering of the GitHub markdown documents, which you could equally get to if you were going into the GitHub. I mean, you actually should be able to jump, edit the page on GitHub, takes you right to the GitHub page. And this has been really important for us because it allows people to maintain and retrieve the latest documentation even if their install isn't. We've been talking about removing that whole component and just using online documentation. More detailed than you probably wanted, but that's a complete tour of the UI so that you can see how things operate and hopefully get a better sense. The next video we're going to go through goes down into booting nodes, and actually we'll walk you through the steps of doing that and using the Ready State Wizard for a provisioning step. I'll talk to you then.